For the first one, it gave you triangle KLM, so I just sketched a triangle KLM to get a visual. It gave us side K, which was 10. Side K is opposite angle K. It gave us side M, which was 4.8. And it gave us the measure of K, which was 96. They wanted us to find the measure of M. So sine of 96 over 10 equals sine of M over 4.8. All right, sine of the angle over the side equals sine of the angle over the side. And all I did was cross multiply here. 4.8 times 90 sine of 96 equals 10 times sine of M. Divide both sides by 10. So the sine of M is 4.8 times sine of 96 over 10. So that means the inverse sine is going to give you the angle. Inverse sine of 4.8 times sine of 96 divided by 10. That rounds to 29 degrees. All right, questions on that one? So for this one, they wanted us to solve the triangle. Solve the triangle means list every angle and every side, all right? They gave the triangle WXY. So again, I just sketched one. You can see actually when I finally solve it that my sketch was nowhere near what it actually looks like. But that's fine. I just sketched one. They gave me the measure of Y, 112, and the side Y, 56. Then they gave me the side X, 20. So I did not have angle X or angle W, and I did not have side W. All right? So the first thing I did is I used the ones that have sides and angles. So I used my sine of Y over Y, that's sine of 112 over 56, equals sine of X, which I did not know, over 20. And I did cross multiplication just like the problem I just did. Because I was solving for the angle, I used the inverse function here, put that in, and I got approximately 19.3 degrees. So that's 19.3. At this point, to solve for my third angle, all I did was use my knowledge of 180 degrees. 180 minus the 19.3 plus the 112 gave me the 48.7. And that would be my third angle in this triangle, 48.7. So I now have all three angles solved, and I have two of the sides. So to solve this triangle completely, I need this third side. So I used law of sines again. You'll notice I went back to my y angle, 112 over 56, because that one is not rounded. That was given to me. So I went back to my original angle, and that equals the sine of 48.7 over w. And then I did my cross multiplication and solved to find the side of 45.4. Because you weren't solving for an angle, you used just sine here, not inverse sine, just sine. All right, so this one's from homework 31. This is a quadrilateral ABCD. You have some notation here that tells you this side is congruent to this side, and this side is congruent to that side. So I can automatically mark this as a 12 right here. They want the perimeter, so as long as I solve for one of these sides, I can solve for perimeter. So I'm going to use my law of sines. I'm going to say the sine of B, which is sine of 28, over the side B, which is 12, should equal sine of D, which is 40, over the side D, which is the one I'm looking for. All right, cross multiplication here. D times the sine of 28 equals 12 times the sine of 40. Divide both sides by the sine of 28. All right. All right, so they rounded 16.4 here. If that's 16.4, then this is also 16.4. That's where you got the 0.9. They didn't round, so they actually just doubled this and then added 24 to it. And when you do that, you get, so they kept going with this one, so they would have done like 4.3 here. That's how they got 56.9. So 56.8, if you just did the 16.4, or if you kept it in your calculator, it would round to 56.9 there when you added all that up. When it says two radar stations are 20 miles apart, located a plane at the same time. So station A saw the plane and station B saw the plane. The first station indicated that the position of the plane made an angle of 43 degrees. So the position of the plane made an angle of 43 degrees. With the line between the stations. So the line between the stations and the plane made a 43-degree angle. The second station indicated that it made a 48 with the same line. So that means this guy over here is 48 degrees. How far is each station from the plane? All right. So we really need to know the angle here. We can solve for that one. How do we solve for that one? Yeah, just 180 minus the 43 plus the 48. And what do you get when you get that? 89. Yeah, so you should get 89 here. All right. So then we're just going to use our law of sines. Sine of 89 over 20 equals sine of 43 over A. And we're just going to use that as A. All right. Cross multiply there. You will get that A is going to equal 20 times the sine of 43 divided by the sine of 89. When you put it in, round at the end, 13.6 here for that one. And then same thing's going to happen on the other one. You're just going to, see if it'll let me scoot this guy over. You're going to do the same exact thing for B. If this is B, you would say the sine of 89 over 20 equals sine of 48 over B. And again, B is going to equal 20 times the sine of 48 divided by the sine of 89. And you will get your 14.9 there. All right, so this is law of cosines. So with law of cosines, you actually don't really have to have an angle. You can just have three sides. With law of sines, you had to have at least one angle measurement. And if you didn't have one angle measurement, then you had a problem. With this one, you can have the three sides, or you can have an angle but not the side that corresponds to it. All right, and so this is kind of like the counterpart to law of sines. You actually can use them both when you're solving for triangles, because sometimes you have to start with law of cosines and then you're like, oh, now I have an angle and a side, and so I can do law of sines now. Oh, now I have two angles, I can just do 180 minus my two angles. And so you can kind of work with all of the information that you've had. So this is ABC is a triangle with A, B, and C representing the measures of the sides of the opposite angles with measures A, B, and C respectively. All they're saying there is you have angle A, opposite is side A. Angle B, opposite is side B. Angle C is opposite side C. That's all that first sentence says. Then the following equations are true. A squared equals B squared plus C squared minus 2BC cosine of A. This will always follow. If you are talking about the angle A here, that is the side that will be out here. The other two will be these two and these two, okay? So they give you all three of them. B squared, that's going to equal the other two sides, A squared plus C squared minus 2AC cosine of B. So you'll notice the angle and the side on the outside match. That's all you have to remember for these, all right? You don't have to try to memorize these three formulas because you could have a triangle XYZ. Right? Okay, so all you need to know is that the side squared is going to equal the other two sides squared added together minus 2 times the side times the cosine of the angle that's opposite of the one that's over here. So A squared equals B squared plus C squared minus 2BC cosine of A. All right, and that just walks around the triangle. Any side that you pick, the angle opposite is going to be the one that's on the inside, all right? So you'll notice the two ends, the A squared and the cosine of A match. Those are the sides opposite each other, the angle on the side. So let's actually use it. Look at example 1. Find A if C is 8, B is 10, and A is 60, all right? So you'll notice the difference between this and law of sines. In law of sines, I would have had to have had A opposite of 60 to use it. All right, I cannot use law of sines here. I don't have enough information to use law of sines. I do, however, have enough information to use law of cosines. They want me to find side A. So if I'm finding side A, I am going to say that's going to go on the outside. A squared equals, and they've written it for me, so I don't have to rewrite it. A squared here equals my other two sides squared minus 2 times my other two sides cosine of my angle opposite of the side I'm solving for. In this case, A squared is going to equal B squared. So B is opposite of B, C is opposite of C. 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of my A, which is 60. All right?
Would you do for the 2 times?
Just so you know, in your calculator, you can actually do this whole thing. All right? So in your calculator, you have an x squared button. You should, hopefully. So you can do 10 and then hit your x squared button, and it'll square your 10. And you can do your 8 and your x squared button, and it'll do that. Minus, now this is all multiplication, so it should do order of operations here. If you want to just make sure, you can put a parentheses, but 2 times 10 times 8 times the cosine of 60. You can do all of that in your calculator if you have like an 82 or 83 for a TI. Right, so what does this equal? This equals what?
84.
A squared, all right? So if you want to do it in steps, you can then take the square root of your answer. Your calculator should do that. Or in your calculators, before you do all that, you can do this sign, but you do have to do parentheses if you do it like that, all right? So if you do the square root sign, it should open parentheses, do all of that, close parentheses, and enter. Or you can do the square root of your answer. When you do all of that, you should get approximately 9.2. 9.2. So make sure that you can do it in your calculators. Make sure that you can go in your calculators and you get 9.2 for this. All right, they want the measure of angle R. So if they want the measure of angle R, that is going to be what we're going to have cosine of, which means which side needs to be on my outside. R, right? So this is little r, this is little s, this is little q. If I am solving for angle R, then my side R needs to be what I start with. So I'm going to say 23 squared equals 18 squared plus 37 squared minus 2 times 18 times 37 times the cosine of R, which I do not know. Now, I am solving for R, which is buried deep into my formula here. So it means I need to do some just basic algebra skills here to get R by itself, all right? So I'm going to do like I would have done in algebra. I'm going to subtract my 18 squared and my 37 squared, right? And I'm going to do that from both sides. So I'll have 23 squared minus 18 squared minus 37 squared. That leaves me negative 2 times 18 times 37 times the cosine of R, right? So far, so good. Still doing basic algebra. I am going to divide both sides by this to get that cosine of R by itself. All right, so far, so good. Now here's the deal. I am solving for R. Anytime you solve for an angle, what trig function do you need to use? We need to use the inverse function. So for this one, that is going to mean that R, if I'm solving for the angle, then I'm going to use the inverse cosine of all this junk. Now, in your calculator, you're going to have to do a double parentheses if you want to do this all together. You can do it a step at a time and write it all out, but I think you actually may do better doing this. So cosine -1 is going to open a parentheses. You need another parentheses because you have addition and subtraction that you want grouped, right? So we want this to be grouped. We have to tell our calculator that. So in your calculator, you're going to have to do your 23 squared, and you can use your x squared button there, minus your 18 squared, minus your 37 squared, all in their own set of parentheses. And then you're going to say divided by, again, open parentheses, because it does not know that that multiplication is grouped. It will divide just by the -2, and then it'll start multiplying. So in your second group, you have to do -2 times 18 times 37. Close the small parentheses, close your big parentheses, and then you can hit your enter. So on this, when you do all of that, you should get rounded to the nearest tenth. That R equals 29.1 degrees, 29.1 degrees. In example 3, they have given us a triangle, and they want us to select the correct strategy to solve this entire triangle, meaning we want all 3 angles and all 3 sides. All right, and so you're always going to take the path of least resistance. Obviously, law of cosines is not the path of least resistance, but it may be your only option if that's what they've given you. But once you've used it, you could potentially reevaluate and say, okay, how do I solve for the next angle? What can I use, right? And so then you can progressively change what you're doing to solve the rest of this triangle. They've given us KLM. They want us to the nearest degree and sides to the nearest tenth. We have angle K, but we do not have side K. And then we have side M, but no angle M, side L, no angle L. We are going to have to start with law of cosines here, okay? So for law of cosines, I would definitely start with solving for side K. I'm not going to have to do that crazy thing I just did with the inverse thing here because I have angle K. So I'm going to first start with law of cosines and solve for side K. K squared equals my other 2 sides squared, right? Minus 2 times my other 2 sides times the cosine of K, which I know is 51 degrees. All right. And so for this one, I can put all of that into my calculator, right? And I will get approximately 14.2 when I get this one. All right. And so if I'm solving this triangle.
Is that what K equals? Or is that
Yes. Then K equals 14.2. I solve for a side here. Well, You have to square root it, don't forget, but yes. Make sure you square root it. Because k squared equals that, so k is going to equal the root of that. All right? And so I have all three of my sides actually done here with just that. Now, I currently have an angle and the side opposite. I can now move to law of sines, right?
No.
I don't have to use law of cosines again. I now have an angle and its side opposite. So I can say the sine of 51 degrees over 14.2 should equal the sine of, let's say, m over 14, right? And so then I can do cross multiplication. 14 times the sine of 51 degrees divided by 14.2 should equal the sine of m. I need to do what function here, though, to solve for m? Inverse, right? So inverse sine there is going to give me, and they actually solved for L, but it should give me approximately 49 degrees, rounded to the nearest degree. So M is going to equal 49 degrees. All I need is one more angle. What's the easiest way to solve for that angle? Yeah, just use your 180. Just use your 180. 180 minus the 51 plus the 49. It's going to give me what? For my last one, 80, right? 80. And so my last angle here is 80 degrees. I have solved that complete triangle. I started with law of cosines. I moved to law of sines, and then I just moved straight to my knowledge about adding up to 180, right? No need to do law of cosines three times to solve this one, okay?